All right, here we are, Module 3, Data and Business Intelligence. Data without a logical storage order is complicated to use. We need to have structured organization that allows database management systems, DBMS, to be more efficient and get the data we need quickly without error. This slide shows a great diagram of interaction between the user, the database management system, and the database itself. You can really think of the database management system as a middleman, or maybe a librarian who you would go to, well, what used to be a card catalog, or the computer, find what book you want, write that down, go tell the librarian or the DBMS in this case, and they would go to the database, in the library example, all the rows and rows of books, and pull that book, retrieve that information, and return it to you in a timely manner. All of this is really built on an organized database. Just like checking a book out of the library is only quick and efficient as the library system, the database needs to be organized in a logical manner to ensure that we can get data quickly and accurately. Sequential access file structure sounds exactly what you just read. We are storing things based in their order. These could be account numbers starting at 001, going the whole way up to 999 or whatever the end account number is. It's really great for archiving files because it's stored in a logical way and we can easily be accessed. And these are things that don't really need updated. Or at least updated a lot. If we have a Social Security database, really the only time this needs updated is upon a death or a birth. Other than that, your Social Security number is always going to be linked to your name. The only changes in a person's life would be if there was a name change. Random access file structure are for databases that need to be accessed all the time. These could be sales records. These can be reports. We're constantly pulling data, adding data, deleting, and manipulating. They need to be readily available, and typically these are stored on here. They say a magnetic disk to achieve speed, but these would be on a server, could be on a solid state drive, but they're somewhere that many users can access it and change it as needed. Index Sequential Access Method, or ISAM or ISAM, depending on who you're talking to, they'll pronounce it differently. This is really both. We have records that are accessed sequentially and randomly, depending on when they are. And to control this, everything is indexed. The index will point to the location of the data we need to access. Information is on the database, and it can be viewed in two ways. We have the physical view, and this is how it is stored and retrieved on the storage media. And the logical view is how it appears to your end users and how they can organize and retrieve it. This is really dependent on what DBMS you're using and how it's catered toward the user role. Some user roles may have different logical views if they are just, maybe a data entry expert vice a system administrator. Database design can be in a hierarchical model where we show relationships between records and it looks like a tree. We have two slides that we're going to look at this real quick. And then the network model where they're organized differently, but each record can have multiple parent and child records. If we go to the next slide, our hierarchical model, we have supplier A goes down to the siblings for product lines, and then we have each siblings for each individual product 1 through 7, and that goes down and down and down. It's a very straightforward tree-like model. The network model, though, we have multiple forms here. So if we look at our payment of method, multiple invoices can pay with cash. So other ones can pay with credit. So instead of doing a tree-like where invoice 222 would be credit and then 555 would be another one, both of those are still using the credit and they still need to be processed like any other credit transaction. So they're sharing that same child. Same thing for all of our cash payment invoices. We can really break a DBMS down into 5 software components. Your database engine is really the heart of the software. It's responsible for your data storage, manipulation, and your retrieval. This really does convert your logical requests from the user into your reports by interacting with the different parts of the DBMS. Data definition is really defined as the standard commands through which the data structures are defined. It's a computer language that's used to create and modify the structure of all of your objects in the database, your tables, your indexes, Do we drop them? Do we rename them? It really creates and organizes the whole structure, and it's really what the backbone of the database engine is. Data manipulation is exactly what it sounds like. We are adding or modifying our records. Most commonly, this is done in SQL, structured query language. That's by far probably the most popular and widely used. However, you may also run into QBE, query by example. Both of these are just query language programs that help us run and define everything inside our database. Application generation, this is really, think of this as kind of the end user. This is the interface and the entry screens, all of the menus that we could be interacting with the database. You may not be familiar with the term data warehouse. And sometimes you'll hear this as a hypercube, but really it's just a collection of data from many different sources that can be formed together to help decision-making applications generate business intelligence. So really it's a big collection of servers with a whole bunch of data on it that helps us make better business decisions. Going into those decisions are different types of inputs. I'm going to talk about ERPs and CRMs because these terms also might be new for you. ERP, Enterprise Resource Planning Systems. This is really internal organizational data inside the company that helps us plan and operate better. You can think of it that way. CRM, customer relationship management, is kind of what it sounds like. It's customer data that helps us improve the overall customer experience. This could be related to loyalty cards. This could have demographic data, shopping habits on an individual to help us cater our products better to our consumers. Of course, all this information needs to be stored somewhere. There's various degrees to it. Obviously, your raw data is everything involved in that data entry. It's its original form. Summary data breaks this down into different subtotals, and metadata is really just information about data. Who accessed it, what users, when, who was it collected, has it been formatted or converted? It's really how that data has been used and accessed. And of course, the end goal of all of this is the output. Having all the data in the world doesn't help you if you can't get the exact data you need in a timely fashion and broken down to the way you need. And that's really where OLAP comes in, online analytical processing. If you look on page 68 of your book, Exhibit 3.7 really shows a great graphic on how we split this out. In my MIS 102 class for undergrads, we do an OLAP model where we take a few thousand lines of data in a very large Excel spreadsheet. And using OLAP, we can break that down into smaller chunks that are, one, easier to digest, and two, can really get the point across in what we need. On Exhibit 3.7 on page 68, you can imagine this cube as just being thousands and thousands of rows of data based on different products sold, when they were sold, and where they were sold. That by itself can be overwhelming and almost useless when you think about that much data. But we need to break it down into smaller chunks into something we can use. If I want to look at all of the dairy products that were sold in 2012 in the Southwest area, I can easily pull all that data up, or I can look at all of our areas on dairy products, or just pick the variables you want, and OLAP will be able to spit that out into very easily to digest features. The ability to drill down in OLAP is really the most important part of this, and this is what makes large sets of data be better to be consumed by individuals. Because you have to think, when you are doing certain reports for your organization, not everybody in there will be a quote-unquote numbers person. They're not going to be an analyst. So we need to make sure that the same data, we don't want to manipulate the data. We want the same answers, but we want the data to be digestible by different people of different experience levels, different education levels to get to the same answer. And that's really the key point of databases, taking large amounts of raw data and drilling it down into something very usable and very compact and easy to understand. So a little shorter video for this one. Not that Module 3 is any less important. There's definitely a lot of information here, and some of this very well may be new to you. If you have any questions, as always, please reach out. Thank you.